In this video, we're going to begin our discussion with linear regression. Now, linear regression is going to be using two variables. So near the beginning of the term, we talked about analysis in terms of a single variable, so one variable analysis. This is when we took a data set and we called data just X then. So maybe we'd have this column of data in terms of X, and then we did things like graph it using dot plots and histograms. We talked about means, standard deviation, all these pieces to describe that single variable. What we're moving to now in this section is two variable analysis. What we're going to have is two columns of data. It could be rows as well, but typically we'll see it coming through as columns, or we'll have some variable X, that's some numerical data that's been collected, and then we'll have this second variable, which we'll call Y, which will have its own data. And then what we want to do is see how do those relate to each other. Is there some sort of association coming through with what we're doing? We want to see linear association, so we want to see a line or roughly a line form with them. But what this will come through is we're going to start with graphs. Kind of like with one variable analysis, we started with graphs and then we moved on to the analysis. Same idea here. Just when we get a second variable, our graphs are going to look a little bit different. So where we're going to start is graphing scatterplots. Scatterplots are going to be a way of displaying our two variables. Now X and Y do relate to how we work with X and Y in algebra, in that in algebra we call X the independent variable. So that's where you could work with equations and just choose values for X. And then Y is called the dependent variable. It typically changes based on your value of X. And that's going to come through here as well. In fact, at the bottom of this page, you can see some alternate definitions for Y, which is our dependent variable. So that's going to typically change in response to what value we have for X. So that change in response is why we call that the response variable. And then explanatory variable operates independently typically, so it just kind of occurs, and with that we call that the explanatory variable since it would explain the response we're seeing in Y. So with that, with our data, sometimes it's clear which would be explanatory and which would be response, but we'd want to think about our variables and how they behave together to figure out which one is X and which one's Y. In most cases in our class, it's going to be given to you. You'll be able to tell which is X or Y, or even from the order that they give you the data, your first column's typically X, and then second column's typically Y. But there is thought behind it to the relationship. And sometimes they're interchangeable, but oftentimes there's a specific relationship. So we're going to look at this data that relates temperature outside to the chirps per second from crickets. So if we think about which is explanatory and which is response here, you could kind of think about the sentence of like which value would respond to the other. So saying like temperature responds to chirps per second from crickets, that feels a little strange. Like temperature isn't going to change based on how many chirps per second we hear outside. If I flip that sentence and say chirps per second from crickets respond to temperature, while we don't know if that's a fact or not, that seems like a relationship that could occur. Based on temperature outside, maybe the crickets chirp more or less, and that's what we want to see with our data. So fitting that sentence of which could respond to the other can figure out your explanatory and response variables. So we call temperature explanatory and chirps per second response because that's the relationship that we kind of expect to come through. Things like temperature and time, or just values that are influenced by something we can't really control, like we can't control the temperature outside, we can't control time is just passing, those are typically independent, so those will often come through as our value for X. So we have our table, and we have these values for X and Y, and something that's important is that if we read across the row, these two values relate to each other. This is a single observation where they saw a temperature of 89 degrees Fahrenheit outside, and at that same moment they recorded 20 chirps per second from crickets. And then if we go to our next value, it was 93 degrees outside, and there were 20 chirps per second. So what's happening here is we can see data and there's a relationship between them. They're typically coming from a single observation, and then it's that we have all of these different observations. So once we collect all of these separate observations, we want to see the trend that comes through, and that's where we start graphing. So graphing, we're getting values for x, we're getting values for y, and they're connected to each other. So what we want to do is go back to graphing that we do in algebra and plot xy coordinates. So what this would look like is, if we have 89 degrees and 20 chirps per second, I'd want to find that. So x value of 89 is about here, and then go up to my y value of 20, which is about right there. So I plotted this point that matches up roughly with 8920 to show where that value's plot. And then I could go to 93, which would be about here, 20, and that would be my next dot. So we go through and do that for all of these. Just so you don't have to sit and watch me make a bunch of dots, I'm going to go ahead and just skip ahead. So here's all the dots plot from our graph. Something I didn't emphasize at the beginning of this was setting up our axes. So typically we'll be in our first quadrant, so you can set up axes along the left and the bottom. And then for a number line, so your x-coordinates will go along the horizontal line here, so our x-axis. And then I just kind of looked for minimum and maximum through these numbers here. So I think the lowest value is 69, and the largest values in the 90s. And since the data starts at just above 60, I used that line break that we looked at when we talked about histograms, so I could jump up the number line and then set a scale that worked for my data. And then the y-axis, which is going to be the chirps per second, just kind of look at minimum and maximum values there and set up your number line. Since it's really focused between 14 and 20, I jumped ahead to 13 and then used a scale of 1 just so it can kind of spread out. With these scatter plots, it's a tough to draw them by hand and get an idea of how it'll best show your data, because if I used a smaller scale, if I kind of zoomed out further, it could be hard to see the trend that's going on. But what we'll get to is I will show you in GeoGebra how to make these, and it'll scale accordingly. So now that we can see our graph, we can start talking about the trend of our data and what we're seeing. So with the scatter plots, it's showing each dot as an individual value. You won't do any sort of connecting of the dots or anything like we do in algebra. With this, we want to see the scatter of them. So what we can see overall is this trend of generally increasing, and it's very general with these, especially with small data sets. But overall, I could imagine this kind of line that's tracking the data that maybe looks something like that. And with that, I can see this overall increasing trend. So with that, I'm starting to see that higher temperatures have higher chirps per second, and then lower temperatures have lower chirps per second. So this first question asks, is an increased number of chirps per second caused by an increase in temperature? And what we want to be careful of are these claims of causation, cause and effect. And with that, even though we see the trend, we can't say that one thing is causing another. So no, we can't claim causation. This is observational data, meaning they just went out and observed. There was no sort of experiment occurring. They weren't doing everything we talked about in terms of experiment of having a control and treatment group and things like that. This is just observational data, and with observational data we want to be careful because of those lurking variables. It could be that temperature change does change chirps per second, but what we don't know is if there's something else out there. Does a change in temperature change the amount of predators that are out, and that's why they chirp differently? I mean, I'm just making stuff up here, but it could be that temperature change is affecting something else, which is actually changing the cricket's behavior. So we don't know about those lurking variables, so we can't claim cause and effect. What we can do is use different wording of what we're seeing happen in general. What we could say is, in general, chirps per second tends to increase with temperature. So we want to bring through this kind of, I always think of it as this looser wording. It's not as definite as one thing causing another. We can talk about tends to, or what's happening in general, or we could talk about association is going to be another word that comes up. We can see this association between the two variables or this relationship, but we can't say directly that one change causes another. Okay, to revisit down here, we talked about explanatory and response variables, and we talked about in general we'd expect chirps per second to respond, while explanatory variables that would explain that response we would assume would be temperature in this case. And in terms of deciding which one's explanatory and which one's response, you can think of it in terms of this statement here of the explanatory explaining some change in the response variable. So for us, that temperature might explain changes in the chirps per second. And then again, this statement of we just want to be careful that we don't use the word causes, since we won't know that, since we'll mostly be dealing with observational data. But we can talk about prediction, association, trends, what tends to happen, but we want to avoid any claims of cause and effect. So now that we know how to make our scatter plot and see a general trend, in the next video we'll talk about describing what we're seeing more specifically.